Good morning, afternoon, and evening, everyone, and thank you all for joining us today. My name is Rashmita, and I am the event planner for Microsoft Reactor India. This session will run over the next 60 minutes, including Q&A. But before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat section will be open throughout, and we do encourage you all to participate. So please feel free to drop all your questions in the chat section. I would now like to welcome our speaker for today's session, Ruth and Vinayak. Ruth is a principal cloud advocate at Microsoft. She specializes in Java, advanced analytics, data platform, and artificial intelligence. Our next speaker, Vinayak, works as a CTO in residence at Microsoft for Startup, helping startup to scale their products. But for now, let me bring them into the stream. There you
Hi
go.
everyone. I hope you can hear me all right. I don't see Ruth yet, but yeah. So let me just start with the introduction to the session. So my name is Vinayak Hegde, and I'm the CTO in residence at Microsoft for Startups. I help startups scale their tech stack, teams, and products. And today's session is a third part in the series of responsible AI and trustworthy AI systems that we have done. So most likely some of you have attended the first two session and are here for the third. So responsible AI is an important consideration for startups for building production systems. It's not one of those things that can be bolted on once the system goes to production or just before that. It needs to be an integral part of the system from the get-go, whether it is the dev environment, testing, whether it's staging or production. If you are a consumer startup or B2C startup, then the wrong responses by the bot or co-pilots that you have can cause consumer complaints. They can cause churn and loss of reputation, especially if things are posted on social media. And you've seen such instance happen in the past. In addition, there can be fines by the regulator or government in question. Similarly, in a B2B startup, especially in high risk scenarios, if you are especially if you're working in highly regulated sectors which have high impact on human if things go wrong, like fintech, like insurance, or for example, healthcare. People will be making people who are making buying decisions and sitting on a procurement panel will definitely ask you questions about explainability, fairness, transparency, and accountability. So they will not buy a product that does not do well on these parameters. However, the tooling in this space is evolving quickly to help startups build better, robust, and fair and explainable systems. And building with this in mind, we have designed this series, and this is third of the three-part series. So we'll post the links to the first part, which was on Azure Content Safety. The second part was on Azure ML Prompt Flow, which was done on 7th March. And then today we have Ruth, who is going to talk about the responsible AI dashboard. So with that, I think over to you, Ruth. We can start the session. And with that, what we will do is, if you have any questions, please keep them coming in the chat. And whenever there's a short break in the presentation, I think Ruth can ask me for the questions, and I will relay your questions to her. So we will be answering those questions as we go along. So let's keep it interactive. Let keep asking your questions in the chat, and hoping to hear from you on how to build, how you have benefited from the series. With that, over to you, Ruth. Looking forward to the session, especially on traditional machine learning systems, in addition to the LLMs that we've covered earlier. Thank you.
Okay. Thank you for the nice introduction. And also, thanks for the invite to talk to the startup community. I always love engaging with this community. So, similar to what Vinayak mentioned, this is a three-part series. So, the first two series we covered were tools and services that you can utilize when you're creating generative AI solutions, and how to incorporate responsible AI tooling um, to safeguard your system and prevent any undesirable behaviors from your AI systems or application. In today's session, we're going to focus on traditional machine learning models. I know in the past year or so, the craze is around generative AI models, but we also want to cater to people that are still training their responsible machine learning models and the awesome tools that are out there to assist them in addressing some of the responsible AI concerns. So Vinyak already gave an introduction of me, so let's get into the slides. So give me a second. So in this session, what we're going to cover is the Responsible AI dashboard. It's a very nice one-pane dashboard that you can utilize to debug your entire model. It has different components, and each component serves a different need. One of the components is on error analysis, so we'll cover error analysis, perform an error analysis on a model. How to find inconsistencies in model performance metrics. Then the next one is, okay, what are the telltale signs or ways of exposing data biases? Then finally, we're going to get into explaining and interpreting AI models. Then we'll get into the exercise. So the very first thing I want you guys to do is if you have your phone, just take out the QR code, take a snapshot of that. That will lead you to the workshop that we are working on, or you can go directly to the website where the responsible AI dashboard is. I'm typing in also another link to go to the entire workshop, just in case you weren't here for the original series. So give me a second. Let me enter back in. My mouse is acting up today. Okay, there. So, Rash Midi, if you can please share the website, that will be also helpful. So to continue with this, I know we went over some of the overview of responsible AI, but for this session, we'll breeze through that. We went into more depth into responsible AI and the state of AI right now. So I'm not going to go too much into that since this is a long and comprehensive lab. The lab that you're going to be running is on Microsoft Learn. That means it's free. You don't need to add your subscription to run the lab. In the workshop, there are two parts. We're using University of California, I think is Irvine, their diabetes data set. So this is a classification model that basically is trying to determine that for diabetes patients that were discharged from a hospital, what are the chances of them returning back to the hospital within 30 days. So that's what the very first workshop would be. The notebook, workshop, the first notebook in the workshop would be, so one thing I need to point out is a lot of people ask, okay, how can I get my model to the dashboard in order to debug it? As you can see, when we go over that spreadsheet, things are not going to be different from what you're used to be doing. The only thing that will be different is the wrapper around calling SDKs for Azure Machine Learning in order to connect to the Azure Machine Learning Studio. Then the second workshop will be actually talking about how to configure your dashboard. So having said that, let's get into the weeds of things. So I'm going to breeze through this since we already covered this in the past. The state of AI right now, we're seeing a lot of rapid breakthroughs and innovations in AI, which is exciting. A lot of companies are adapting AI to give themselves a competitive edge. They're also using internal business processes within their organization using AI to make themselves a little more productive. Then one thing we're also seeing is public excitement, adoption, and also on the negative side, seeing scrutiny. On a daily basis, on the news headlines, we see the misuse or use of AI. And with all of this outcry, governments are also responding and stepping in to help regulate AI. So as a startup, this is something that you should pay attention. And Vinayak already has gone into details in some of the consequences that you should consider. So for us sitting here, we're a technical environment. So the question is, what does that all have to do with us? Like the responsible AI principles, what does that have to do? So number one, there's a challenge when it comes to data scientists. For the majority of things, we don't set out, or data developers don't set out to say, yes, guess what? Today I am going to train a model to be as biased as possible, unfair as possible. No, that's not the case. Some of these issues that come up are unintentional and sometimes undetected. But the problem organizations, startups, and AI practitioners are facing is we don't have the tooling. There's a lack of tooling to actually debug these models. And we'll get into details around that. The next thing is responsible AI is very important because guess what? A lot of decisions are made based upon AI. So decision makers are depending on the AI systems or solutions to be correct in order to make informed decisions that affect maybe the company or individuals or the public. Lastly, developers on the other end need toolings, and also the end users need to have some kind of trust that they are dealing with a trustworthy application. So one thing to mention here is by the time you get to the end user, whatever harms or undesirable behaviors that the users get also affects the reputation of your startup. So that's one thing to keep in mind. So what is the solution to all of this? The solution is Microsoft it has been instrumental in their research, in participating in open source research on how to provide tooling for the data science community on how to actually debug, because I'm sure everybody knows all the principles, fairness, accountability, inclusiveness, security, transparency. We all know that. But at the end of the day, what are the actual practical tools that if I create my model, I have a human-centric way of measuring whether my model is potentially going to be causing harm to the end users. So kind of like how I mentioned, Microsoft, other organizations out there, and a lot of academic um, universities out there have put in research into open source tools, and each of them have created different toolings on how to debug responsible AI. So we'll go into details of that. But on a high level, what I want to point out to you is we do have responsible AI toolbox. This is something that Microsoft has made available. It's open source and free for the community. Then with added benefits, it's also integrated with the Azure Machine Learning Studio as well, so you can utilize that. So the same dashboard is available open source and in person. If you can copy the link to this URL, there's a very nice video that gives you an overview of the dashboard for you to appreciate the power of it. There's a lot of the components we're not going to cover in this lab. We'll cover the critical common ones that data scientists or AI engineers run into. The next thing is, let's skip that. So kind of like how I mentioned, I'm not going to go into details of the 6 principles because we covered in the first series and the second series. So if you want to know more details when we're talking about responsible AI with Microsoft, these are the 6 principles that we're talking about. And we go a little more details into other what each of them means. Another thing I want to point out is remember how I mentioned that this is a cumulative collaboration, or a lot of parties have participated into developing tools to enable the data scientists and data practitioners, AI practitioners, to debug their models. There's a company called erroranalysis.ai. They focus on you identifying issues in your model and which demographics are affecting. So where is your model failing? So that's one thing. We have Interpret ML. So that one deals with explainability and interpretability when it comes to transparency. We have Fair Learn. That's the one that focus on sensitive areas that maybe your models are not being fair. So let's say you have features like gender, age, race. Fair Learn is a very good company, and also a library that you can utilize within Python to debug your model. Dice is a tool from Microsoft that deals with causal inference as well as econ ML. So if you notice, all of this are packaged into one. So when we call the responsible AI dashboard, it's really open source driven. So on the debugging side, I'm sure you're asking, what are these questions? What are the things that I benefit as a developer? So one is the error analysis, one is data exploration, other one is model overview. You do fairness assessment, model interpretability, counterfactuals. Then we also have something for decision makers too. So causal analysis and counterfactual what ifs. Don't worry that I'm quickly going through all of this. We're going to go through all of those different components and explain exactly what is going on. So basically, what the flow is, number one, identifying what kinds of errors you're getting from your model. What are the areas where your model is being erroneous? Number two, the second tier is okay, how do we diagnose what exactly is causing this model to fail? Then the next thing is okay, now we know that we have issues with our model. How do we solve it? So um, it provides a recommendation and options for you to go out there and fix the model. So this is kind of redundant in terms of the decision maker. We we're not covering this in the lab, but with the same link that we gave you for the workshop, we provide a very comprehensive walkthrough that discusses all of those into the provided video in the workshop. And if you need the URL, this is a URL that goes through more details into some of those components that we're not covering. So now let's get into the components and talk about what you're going to be seeing and why this and the power of this dashboard. So number one is error analysis. So in school, what we learn for the most part is after you train your model, you have to perform model performance metrics. The problem with this approach is very numeric score based. It's a lot of mathematical computation. So let's say you have a model that says, hey, it's 98% accurate. This is actually good, depending on what your use case is. But in reality, what is really going on is there are certain demographics within your data set that this model is always 100% accurate. There could be another important demographic that your model is only 59% accurate. There's probably another demographic that is 48% accurate. So as you can see, this is not a human-centric way of debugging, or there's also blind spots even when we're given this accuracy to figure out, okay, what exactly is going on, even if you're able to expose the percentage of the breakdown of your model accuracy. What this dashboard does to solve this is give you an error distribution, but on a human-centric side, provide the features and exactly you understand the characteristics of this demographic that the model is failing. And those are areas that you can start to identify potential fairness issues, inclusivity issues, and we'll go more into details with that. The next thing is, okay, you get a model, you see that, okay, the accuracy is 89%, but with our traditional metrics, we also have things like precision that you can measure that, okay, for the, let's say, in our use case, for the diabetes patients that the model said they're going to be returning back to the hospital within 30 days. How true is that? How accurate did they get it right? So that's what that does. So it's still giving you a numeric computation. And this is dealing with a classification type of model. For recall will also expose things like, okay, for all the cases that the patient was actually going to be returned, the likelihood of them returning back to the hospital, um, how did did the model get those correct? You also see if there's a degradation, then there's issues with the model. So this model overview gives you an overall breakdown of these metrics, traditional metrics that you're using. So we're not saying these metrics are wrong. It also shows you things like the false positives and um, false negatives. Another area is also it gives you a visualization of how your features are scoring. So if you have like different groups that you've saved that, okay, for this particular group, it's not performing well on a human-centric way, but I know that the model is erroneous with this group, you still need to debug and figure out what is causing that so you can dive deeper on a feature level to figure out where exactly that issue is occurring. So the next thing is looking at your data distribution. So as you're evaluating your model, the very first thing tips to do is look at your data. So it could be in your data, you have an overrepresentation of a certain demographic and also an underrepresentation of another demographic. So the question I'm going to pose for you, you guys answer in the chat. Which one do you think the model is going to favor more? I'm going to pause for a few seconds. The big or small demographic? Okay. So obviously, this demographic is going to benefit because you have an overrepresentation of data there. And this one, you hardly have, you have an underrepresentation of data. So it looks like the model is not going to be learning well. So just think of, let's say, in a gender situation, this is the number of females and that's the number of males. Depending on what the use case is probably going to be favoring the male demographic and vice versa. So those are telltale signs of identifying where your issues are coming from. And data also tends to be a blind spot that we need to pay attention with. Next thing is we all know AI models are a black box. The good thing about this dashboard is making your model a glass box instead of a black box where you have a little more understanding and you're able to understand, explain exactly what your model is doing. So for you as let's say AI practitioner, what you be looking at is, okay, asking questions. Why did my model make this mistake? Or how can I improve this model? You can get that information from this section from, let's say, human collaboration. How can we understand and trust the model's decisions? That's for making decisions. Then with the regulation and compliancy issues, you can ask the question, does my model satisfy the regulatory requirements? So if you see in this image, the good thing about the dashboard is it gives you an overall view of all your features, but it will give you the top features that are driving your model's prediction. So as you scroll down, the features, their influences get lower. So another question I'll pose to you is, let's say you took the top five use cases, and this is like a loan approval type of scenario. And the top five features for the loan approval were gender, age, and race. Just looking at that without going into details, do you think you have a good model? If your model is the driving point is those sensitive features. Of course, automatically you know that yes, we cannot. This is not going to be a trustworthy application, AI application approval system because it is biased. Is going by bias features. Another thing you can also do is drill down on an individual patient level. So let's say a doctor uses an AI system to make diagnosis, and based upon the diagnosis it got from the AI health system of what a patient has, and let's say they follow the direction of the AI model, and let's say there's a fatality. The question is the doctor going to be pointing to, yes, the AI told me to do this, so this is not my issue in terms of accountability. Um, One thing your model needs to be able to do is pinpoint exactly for that unique individual, because patients are going to be different. So it's not always going to be these top driving features. On the individual level, you can dive down to that individual level and see what were the top driving features that led the model to make the prediction, right or wrong prediction that they made. So that goes to the conclusion of our overview about the dashboard. The next thing we're going to do, hang on, let me bring up the workshop. So give me a few minutes. So actually, while we're doing that, if everybody can go to the QR code for the workshop and open the workshop, that would be awesome. And on my end, let me go to the workshop. Okay, and while I'm doing that, Vinayak, do we have any questions from the audience? Can anyone hear me?
Um, how do we? I think there are some questions about batches, but we'll answer them later.
Okay, that's a good question. Um,
Um, uh, Maybe you want to cover it at the end, Ruth. So there are mostly questions about batches, and I think there are no other questions. There are a couple of comments, but no questions. I mean, some people think that maybe this should be a more important topic than it is given importance, and both me and Ruth completely agree that it's a really
uh-huh,
important topic. Hence, we are doing this series.
yeah.
Yeah, I think there's only one question on the batches, but other than that, there are no technical questions as such.
Okay, so in terms of the badges, if you registered for this workshop and you were able to provide your name and email, we ship that to the team that issues those badges. So before you leave, or we'll send an email to people that attended to make sure they provide their name and email. so the creditly badges can be assigned to them. So I know we have 35 minutes. So let me get to the exciting part of this workshop so we can start appreciating it. So since I mentioned, like I mentioned before, this is a Microsoft Learn workshop. So the very first thing you do is click on Start to start the workshop. It'll give you an overview. If you want a refresher, it goes a little more into details talking about um, the different modules, so you can breeze through that. And some of the things I've already covered, and giving you a background of why those sections are important. So the good thing is we already covered that. So keep navigating. Once you get to the part, the exercise, just click on Launch into Lab. And you're going to do a multi-factor authentication at this point with any, what's it called? Any email that you have. So you don't have to have a Microsoft subscription. So don't worry about that. It should take you directly into the lab. It's going to take about a minute for the lab to launch. So while we're waiting for that, let me navigate to the dashboard so we can have that ready to discuss the dashboard. Okay, so that is taking a while. I don't know whether it's Zoom, when you're sharing things, it takes a little longer, but yeah, I think we have good timing left. So we should be able to breeze through this. So what I'm doing on the Azure portal, later on, you have links in your lab, so don't worry about that. I'm trying to get into my resource group. I created the Azure Machine Learning Studio, so I just need to open that, then have it ready. The next thing is I'm gonna open the studio. So this is Azure Machine Learning Studio. And as we go through the different sections, I can be pointing to you guys exactly what's going on. But it's good to have a visual of the Azure Studio. So it looks like the Azure Studio is taking a while to come up. So let's get back to the lab. Okay, so let's start the lab. Let me maximize the lab so you guys can see. Okay, so I guess loading the lab takes a while. So very first thing, this is tricky at first, so trust me, I do understand. You're gonna come to a page, it asks you for a login. Don't worry, I'm sure you're wondering, okay, where's my login? Just click on the next button. As you go through the steps, you're always gonna see a T. That just denotes that this is a field that the prompt is waiting for you to enter. So the very first thing we did is launch the Windows 11 virtual VM box. So to log into the VM box, we click on the T to enter the password. So once you click on the T and click on next, it's going to populate the password. So now we're in. the next thing we need to do is launch Visual Studio Code, if I can speak this morning. So we're going to launch Visual Studio Code. I'm going to close out of that. The very first thing we need to do is go to terminal at the top. It's asking you to log in. So once again, make sure your prompt is at the terminal and click on T. It will automatically populate the login. Press enter. And that will give you a link for you to log in. So in order to log in, it's going to launch a login page for you to enter credentials. Number one, you're also wondering, okay, what is my email? Don't worry about that. Click on the username here to populate the username. And that's how you're going to log into the workshop. Then the next thing is select the account and click on password. That will populate the password. Once you have that done, voila, you are now authenticated to the Azure subscription. But don't worry, this is not your subscription. This is subscription that's made available to you from the lab. The next thing you want to do, that you need to do, is create the Azure Machine Learning Workspace. So at the command prompt, okay, this is a perfect example. So I clicked on the T before I clicked on the prompt. So if you notice, the text is cut off. So just in case you're getting errors and you don't understand, you can erase and make sure you do have your cursor before you click on the T. So populate the code or the script that you need to create the Azure workspace. While we're doing that, I'm going to skip a little because this takes a while. The next step, it asks you to launch Notepad. So you actually need to type the word Notepad. And I'll tell you in a second what this is doing. So for this particular workshop that you're working with, it has the name of the Azure workspace that you are creating here. So what this notepad needs is click on a cursor in the notepad, click on the T, and what basically it needs is the subscription number. So in real life, this is actually what you need. Subscription ID for your Azure account, the research group that you created your Azure Machine Learning Studio, and also the name of the Azure Machine Learning workshop, workspace. Why do you need this? It needs this information in order to authenticate to the cloud when it needs to, when you're training your model, and when it needs to use the SDK to connect to your cloud. You already used is going to be using these credentials to log in. So what it asks you to do here is name this file as config.json. So what we're going to do is do save as, and we're going to give it config, and make sure it's not a text. Make sure the extension is .json and type. Then the next thing it asks you to do is navigate. We're going to go to the C drive, navigate to this folder. So it's lab files, the lab name, um, than the workshop. So what we're going to do is put it in the general repository. And voila, we're done. So the first script that you ran here, we ran here, went successfully. The next thing is it just wants you to set the workspace as a default. So it's like a default environment. So we click on that cursor, and this should be quick in terms of setting the environment. So once you have this ready, you can click on next. I'm not gonna run the, what's it called? I'm not gonna run the lab because for each notebook, it takes about 10 minutes to run. But I'm gonna give you guys an idea, walk you through what the code is doing. So similar to how I mentioned earlier, this is what you're used to doing in your everyday. So um, the same way you're training your code, let's say you bring in your data set, you identify what column is your target column for the classification. You allocate your training data and the test data set. You have the pre-processing steps that you want to do. So like encoding your fields or columns, you can do all those pre-processing steps. Select the model you want to utilize, then go into training. And when you run this in real time, it's going to print out the accuracy score of 30, I think, no, 83. So you ran the lab, right? You completed, you trained the model. The next thing, this is the SDK that you're going to use to connect the client to create a client and connect to the Azure Machine Learning Studio. The next thing is, let's say you are doing data wrangling and cleansing your data. Best practices is to store your data in the Azure data set tab. And the good thing is, as you run more experiments, let's say, and especially in an auditing type of scenario, you may want to keep track for every experiment in links to the data set that you utilize. And it could be other people also using this data set for different experiments in a real life, realistic situation. Then the next thing is we're creating a compute because what we're going to do is put this into a pipeline to run the whole process when you submit this to a compute to connect to the dashboard and run some of these processes. So we're just creating a VM compute. The next thing, that's what that is. Then the final thing is we're creating a job. And the job is basically specifying what your experiment is, what your compute is, what your data is, what is the source code. So if you put in the source code that pass in the data, the target field, and where I should put the model output, this job actually would train your model and in the Azure portal. So you can run it locally or you can run it in the Azure portal. I feel like I'm scrolling up instead of down. Then the last thing you're doing is registering your model in the Azure portal. So that's what you're doing. The next thing that you need to do, this is now different from what you're used to. The very first thing we're going to do is create a client to connect to the Azure Azure Machine Learning workspace that you created. Remember the config file that is in your environment variable. It's going to utilize that config file to authenticate in order to connect to um, your Azure Machine Learning Studio. The next thing is for the dashboard. This will make sense later. It needs to understand what your categorical fields, what are the text fields. So you have numeric and also string fields. So basically we just have a helper function that is extracting all the fields that are strings, categorical fields. So this is actually the components the um, the dashboard. These are the ones that we're going to use for the lab, but there are other components. So if you go to Azure dashboard, Azure Responsible AI dashboard, you'll be able to see other components, and each of the components are named like this. In the instruction, you should be able to get a link to where to find that. So this is what you're selecting that you want to be displayed on your dashboard. These are the components you need. Okay, now you're defining your dashboard. So the very first thing the dashboard you're doing, you're also going to put it into a job pipeline. The very first thing you're going to do is enter the compute for the pipeline to run, description of what the dashboard is doing, the experiment name, and you can do versioning. These are inputs to your dashboard. This is also something that I'll show you the visual that will make sense later. But the main thing, whether you trained your model locally or in the cloud, the main thing that you need is, okay, what is the target for this classification, your classification model? What is the target field that you're trying to make a prediction? So you have that. What is the training data? What is the testing data set? Those are the inputs you need to pass in order to create a dashboard. So with this dashboard, the configuration, you give it a title you want the dashboard to be. Next thing, this part is important. You need to give the type of model it is. So is it classification or is it regression? This is important because based upon what type of model it is, when the dashboard comes, it'll come with the relevant what's it called, metrics, performance metrics that deal with the type of model that you created. The next thing you're doing is just specifying the model path to the model that you registered in the cloud. Remember the data set that you created in the last notebook. You're just specifying that go grab that data set. You're setting the target column and the categorical column. So that's how you go ahead and configure your dashboard or define where your dashboard should be. All the components that you created above, you're just adding those different components, and each of the components come with different settings. So refer to the Azure link. It will also show you additional fields that you need to add if you want certain metrics to be displayed. Finally, you need to gather all the components that you need for your workshop. So you gather all of that. Then, of course, it has a UX UI. You upload that. So you have just defined what or configured what your dashboard is. This section, all you're doing is submitting this to a job. And the job will basically go through and run this application. So let me pause for a minute. Um, why do we need to put this into a job pipeline? So let me quickly minimize this. When you go to submit the job, when you're running the lab, what it's actually doing is creating a job. And remember all the things that I was mentioning that you were specifying. You're not just specifying it for the specifying it. This is what you were actually doing. So when you kick off the job, um, these were the inputs that you pass into the constructor of the dashboard. So the model, the two data sets, like training and test data sets. This is a constructor. This is the components that you said you wanted. Then it gathered everything and ran the insights for the model. If you have other components, it could be 6 other components there. So that's what you did. Remember how I mentioned that for your tests and data inputs, in our case, we had Parquet files. So what we called is hospital test Parquet and hospital train Parquet. This is a centralized way that you create your data once. You don't need to move it. All you need to do is reference it. So it saves the hassle of moving your data around for your experiments. So the next thing is in the very first notebook, when you trained your model, you registered it and you gave it a name. This is where you registered the model. So you click on the model. The next thing you do is go to responsible AI. So this is where all the magic happens. So I see we're at time, so I'll try and quickly breeze through this so you guys can have questions. And let me, is this font okay, guys? Quickly let me know. Okay, I'll take it as a yes. So remember that screen that I showed you guys that, let's say your AI model came and told you, hey, this model is 98% accurate, and you're jumping up and down like, yes, let's launch this. Guess what? Remember those different demographics I was mentioning that your model could be internally failing? This is a good visual way of you to identify those. So at the node, when you click on the node, it's showing you this is a total test data that you provided. When it did the evaluation for the dashboard to gather metrics, these are how many records that were correct. And these are how many that were incorrect. So total incorrect, total incorrect. So this is all the data set. So since I mentioned that this, our problem, the current challenge right now is performance metrics are numeric based and score based. It has nothing to do with figuring out whether this is going to harm an individual or not. This dashboard is human centric. So click on any of these nodes. So if I click on this, okay, I forgot. So it shows you this node for all the diabetes patient. The errors are coming from a demographic of patients that have prior inpatients. So that means they have prior hospitalization greater than 0. If I click on this, it gives me information, another vital information. Out of that demographic, the ones that also, on top of prior hospitalization, the ones that have lab work greater than 56 are the demographic that the model has the highest errors is failing. So the question that you're asking is, why do you know that it has the highest rate? So the good thing is the dashboard gives you a cheat sheet. So see this red color, the darker the red, that's showing you that this demographic, this whole branch, is the one with the highest error rate. Then the lesser the red, it shows the lower the error rates are. So these are also high error rates. But when they're gray like this, it shows you where the lowest error rate is. So what you're doing is under the error analysis, all you need to do is, okay, I'm in debugging mode, right? So all I want to do is figure out what is going on with this demographic. So you can click on new cohort, or you can create a new cohort. Cohort just means I'm creating a subgroup. So I'm going to put this ERR just to let me know that, listen, just in case I'm going to create multiple groups. I just need to know that this one was the one with the highest error rate. So I'll call it lab work. You can give it whatever name that you want. So the next lab work greater than 58. The next is I'm going to give it prior. I'll give a hosp. So that means prior hospital greater than 0. So they've been in the hospital. So, okay, that's that. The next one is I need to figure out which one has the lowest error rate. So one thing you can do is as you hover in any of these nodes, right? Let me increase the resolution just in case people can see. Any of these nodes, when you hover over it, it's also giving you information. It's showing you that for this particular demographic, this is where gender is male. So, and prior intake is greater than 1. If you look in just the ones that are male that fall in this demographic, this is a number of males that the AI got incorrect and correct. Then the error rate is just the error rate between the total it got correct versus the total it got incorrect. That's how you is coming up with the error rate. What is error coverage? The error coverage is basically saying that, guess what? Out of these errors, there are 11.61 percent contribution. Like errors coming from this is how much percentage is contributing to this error over here. So all of these will have error coverage. Okay, well, you guys play around with that, but that's what that basically means. So I created a group for the most error rates. So the next thing I want to do is quickly create a group for the ones that have low error rate, because what is so special about this group that is performing very well, and the other one is performing poorly, and you can create other cohorts to do this investigation, because maybe 2 is not enough, but for the sake of time and this lab, I'll quickly create this. And prior hospital is less than, so these, this demographic is people that had lab work less than 8, are female, and also have no prior hospitalization. So when you create this, you're like, okay, what just happened? Click on this gear. It'll show all the different cohorts that you created or subgroups. also show how many people in that demographic fall in that demographic. Since we're using such a small use case, it is small, so maybe some people will be like, okay, maybe that's not a big deal. But let's say you're dealing with a data set of, let's say, 5,000, and it's like 500 in one demographic, that's the issue. So similar as how I was mentioning, remember, this is all our data. This is what we're used to seeing today. When we create a model, we have the test data. This is the size of the test data. Um, Remember, when you run it, you see that in your notebook, this is the accuracy score that I gave it, but that's overall. So we're jumping up and down that, yes, we have a high accuracy. But if you look at the demographic of diabetes patients that have these characteristics, they're 38, and look at how the model is performing. The model is only accurate 59% of the time, and the one that the model is performing well, 26 is for 26 patients out of this 696 that the model is always accurate. So the next thing we need to look at is the false positive rate. It'll show you all of that, and the false negative rate. So as we can see, it looks like the model is having trouble predicting patients that would be readmitted in 30 days. How does that have to do with responsible AI? If somebody came into a hospital, you discharge them, and they are at high risk, and they go to back home or wherever facility that you sent them to, and they're a high risk, and you don't follow up, there could be a fatality. So that's also causing harm because you incorrectly said this person is good to go, send them home, and they're ready to return to their everyday life. Another good thing about this dashboard is it'll give you the probability of these groups. So look at the bottom. It's showing, okay, what is the probability of this three groups being not readmitted in 30 days? So it looks like everything is looking high. All the data, it looks like most people are these are the probability of them not being readmitted. Even the error, one with the error rate, there's a 90% probability. So this looks pretty good. Another thing that you can also do is do the reverse, okay? Out of all these groups, which ones has the highest probability of being readmitted? So if you notice, all the data is kind of on the lower side, but still the erroneous one, since there are issues, the model is not getting it correct, it's higher. So that helps you wonder, Then the next thing you can do is, remember, we already look at accuracy, right? We're good with accuracy. Another thing you can do is play around with other metrics that we're used to. So we're going to look at the precision. Remember, all the data was 83% accurate. Whoa, it just went down. So that means for the model, the ones that's predicting that people are going to be returned back to the hospital in 30 days, out of the ones that it predicted that they will return, there's a 69% accuracy. Then what about recall? This is all the data. All the people that were going to be readmitted, we know they're going to be readmitted. How did the model perform? Gee, we went from 98%, 93% that were doing cartwheels, that was doing very well, to less than 20%. So you know there's a problem. So these are the disparities that you need to look at. It also gives you a good confusion metric. Another area I want to quickly show you is we have all of these, but you can also, as you want to isolate and look at, okay, what could be some of the features that are driving um, the model not to perform well. It could be the impatient is a common telltale sign. Maybe it's the one skewing the numbers. So the good thing is automatically it breaks it down into these groups, subgroups, or partition. You can see the group, the ones less than 4 hospitalization are doing, this is the number that fall within that category, and this is how well the model is doing. So these are other ways that you can use to debug your model. So that's the overview of the model overview. But in the lab, you understand more details. I'm just doing a quick drive-by to give you guys the gist of how you can do more human-centric debugging to start sensing how this is behaving on societal use cases or individual use cases that can turn into an undesirable uh, outcome. So the next thing is data analysis. You can also look at the data. So all the features, all that you have in your data, you have here. So you can look at the tabular view. It shows the actual outcome and what your model predicted. So this is how many the individual records that were correct and the individuals that were incorrect. So another thing you can do is look at the chart. So one of the things that you can do is click on this and say, okay, first of all, I just want to look at what the distribution of the data is for this hospital data set. So we see that most people are not readmitted, which is good. For a hospital, you don't want a whole bunch of people being readmitted. So that's good. But the fact that the model was not performing well can attribute to the fact that we have such a low number data set of people that are readmitted, understanding characteristics about this group. The model is not learning here. Okay, so that's the number one telltale sign. Let's see what the model is actually predicting. Oh, wow. So it's even bad. It's not predicting well. Another thing you can also do is, well, I forgot, I refresh. Anytime you refresh, you're going to lose the cohorts. But one thing you can do is the different cohorts that you created, like the most erroneous, also select that and see how out of that demographic, how is the model distribution, how is this behaving? Another thing we can look at is, okay, let's count certain sensitive demographics that could potentially pose a problem based upon your data set. So let's look at things as race. So we see Caucasians being the highest population, then African American the next. Okay, then Hispanic and Asian, then other. Okay, get an idea of how our data is distributed. Okay, what about gender? Let's look at gender. That's another sensitive area. When we look at gender, it looks like there are more females than male. It's semi close to each other, but maybe that the number of females being more can attribute to, remember when we were looking at that error analysis and we saw the gender for that path of where the model was performing well, they tend to be female. That could be also be a correlation. So that's a good thing about this dashboard. You're seeing certain behaviors, but each different um, component that you go to is enlightening you, things are making a little more sense. You're able to start diagnosing what is really going on with my model. The next thing is, okay, look at the age distribution. People less than 30 are low, then 30 and between 30 and 60 are the next, then over 60 are the highest. And you're like, bravo, we are ready to flag this as another bias area. So the question, the answer is no. This is a prime example why data practitioners need to work very closely with the end experts, like the physicians, and ask, okay, is this a normal distribution? That's number one, of the demographic of where diabetes occurs in this age group, where people start having diabetes symptoms. So that's number one. Then another thing you can still consider is maybe we still need a balance of people that fall under this demographic, because we don't want somebody in this demographic to come in and we say, okay, they're not a problem. Anybody under 30, just ship them out. They're good to go when they could be at risk. Then the final thing I want to touch on this is let's put race here and put prediction. So as you can see, you can play around with all of these metrics. So please, after completing the lab, play around. This is your sandbox. Play around with different scenarios to really understand what's going on. You already had a sense of the data here, the type of data that we have. Even in your notebook, you can use the data frame to do a display or to understand the type of data that we're dealing with. So this is the model, right? For race, this is a prediction. So race-wise, these are people that are going to be readmitted. These are the ones. These are the ones that are not going to be readmitted. These are the ones that are going to be readmitted. Let's take a step back. Can't help where we're collecting the data. So let's say we build a model here in the US, collected the data here in the US. This is a different use case. Of course, there are certain characteristics that are here that the model will perform well. If we take the same AI model and let's say we go to somewhere like the UK, this is a different demographic, or even Africa, the model is going to perform probably different. So we have to be cognizant of where the data is collected and where we're deploying the model. So question to you is, if we deploy this model into multiple different ethnicity groups, um, different distribution of ethnicity groups, how well is the model going to predict? Okay, so with the time, the answer is this model is not reliable. It's not safe, and just go through all, it's not inclusive, all of that, because guess what? If you take this model to a neighborhood that's predominantly Hispanic or African American and less of the Caucasian, then your model is going to be erroneous. So those are some of the examples of what's it called? Um, Having biases, this exposing imbalances of your data and potential biases. Lastly, we're going to cover feature importance. So the good thing about
So Ruth, sorry to interrupt. I think we are almost out of time. Would this be done like in 5 minutes? Because there are a few questions I wanted to take as well.
I'll be done in 2 minutes.
Okay, sure.
Oh, okay. Thank you for letting me know. So similar to how we had for transparency, if you want to figure out what's driving your model, You can scroll up and down and see the breakdown of your features. So as you can see, prior uh, hospitalization is a key driving factor of whether somebody is going to be readmitted or not readmitted. Same as the number of diagnoses or where they're actually being discharged. Is it a facility or your cousin's house? That sort of thing, or a family member. That's another area. Another thing we can do, um, well, the lab already covers that, so I'm not going to go into details. Another thing you can also do is similar to that. You can look at when it comes to transparency, these are the ones that are correct, and these are the ones that are incorrect. So let's look at this particular patient that's African American and female. When you scroll down, guess what? Inpatient is also one of the driving factor, number of diagnosis, destination, but race did not show up in the top five. So each person is different. So you'll be able to determine whether or not they are going to be what's driving the model to make a prediction. In the lab, you can also see what will positively influence. These are what's influencing the model to make a wrong prediction. And this, if it goes under, this is what would influence the model to make the opposite prediction. So the lab will cover all of that. Once you're done with the lab, in order to get credit, I want to add one more thing. Just click on Continue Lab to get the certification. That's how we know how many people completed the lab. So sorry that the number of steps were long, so that's why I wanted to demo it and give you guys the opportunity to actually do the lab in your own time and now in real time. So now I'm free to answer any questions that you have. And thanks for giving me your time as well.
Cool. I think many of the comments I think will disappear after the stream ends. So what we can do is you if you want your batches, I think maybe you can get in touch with Ruth on LinkedIn. There was another. There are a couple of other questions about batches aside. Um, Working with your own data, what is a better approach related to benefits versus costs and work? To use your own data option from AI Studio or OAI, or used to use prompt flow? I think this is probably from the earlier, somebody has seen your earlier session, and maybe that's a question from there as well.
Yeah, that's a good question. So with prompt flow, that's completely different. That you're using generative AI LLMs. So you cannot use LLM models to debug using the dashboard. These are your own data that you brought in and trained your own models. So these are custom models that you trained. So that's why we started with large language models, generative AI, then we're ending with traditional machine learning model training.
Absolutely. I think we have covered the entire spectrum, because I think responsible AI as a concept applies to all models, all parts of AI, right? And because
Mhm.
everything is used in like decision making, hence we need to have like fairness, accountability, and transparency, and explainability as well. Um, there's a question, I think, a comment by Jonathan Lewis says, I don't think that making the same steps provided from Microsoft Learn could be useful. Maybe it's useful to see something already set up and show what we can do and give some helpful tips. I didn't quite understand that question, but Ruth, do you have any comments?
Yeah, so I think I understand that. We already have the data provided, yes, and the environment. So what the lab is showing you is how to train your model, how to configure it into the dashboard, and how to run it. So all of those metrics are gathered for the dashboard in Azure Machine Learning. So with all of that, we're also stepping you through how to use the dashboard to train the model. If you want to, after you do that, if you don't have an Azure subscription, which everybody in this audience has, so that they shouldn't worry about that, because I was going to suggest the Responsible AI Toolbox. That's the open source free version. But yeah, play around with this on the website that we're for the workshop. There's a discussion page. So if you have questions, make sure you also go to the discussion page, and we'll be able to answer that as well.
Cool. Yeah, I think Fool's Nabel, I hope I'm getting the name right. What does debug mean for a model? Yeah, obviously, I think a model is very different from a executable, so that's a very interesting question. I think in this particular context, I think, as far as I know, it means that you want to check what the outputs are given certain inputs, and hence, you want to check the behavior just as you do in a normal testing scenario.
Mhm.
Obviously, it's in a normal testing scenario, it's very deterministic. Here, it's a little more probabilistic. Ruth, you want to add anything?
Yeah, so debugging is kind of like any other Hello World application. As you're also training the model, you can put it in the dashboard and figure out, okay, why is the model not giving me high accuracy? And you can identify the areas. We didn't cover the toolbox, responsible AI toolbox tracker, which is on top of this that shows you how to mitigate issues that you found. So it's not just identifying, it shows you options on how to fix it. Because if we don't debug and you get a 95% percent accuracy and you ship the model out there, this dashboard, we went through different things where we had a high accuracy. We did not know there were all of those issues. So, as a startup, do you want to wait till your reputation, something goes wrong that's harmful to end users and your reputation goes down, is affected negatively? Or do you want to be proactive in um, double checking your model in terms of testing?
Cool. I think those are the questions. Obviously, there were some comments about, can you watch this later? Yes, absolutely, you can. If you're watching this on YouTube, the same link should allow you for replay once the stream ends. So you can go back to the link and check out the workshop once again and follow it through. You can also Rashmita has also posted a link to the channel, so you will also have this available in the channel videos page under live and videos both for Microsoft for Startups and also Reactor page. In addition, I think we also posted a link to the registration page or the Microsoft Reactor page. They will have the videos embedded in them also. So I think you should be able to find those videos through multiple different places. Yes, absolutely, these are recorded and streamed live. But yeah, in case any of your teammates want to see, or any of you want to see the earlier episodes, you can go ahead and do that.
Rashmita, if you can quickly show the screen. Okay, so these are the three-part workshops that we covered. This is a discussion page. So as you go in real time and at your own pace, you have questions or you run into issues, go here and post any questions or issues or badge or anything. And we're monitoring this and we'll provide a response to you. So the goal is to empower you in all of these subjects, so you can not feel lost when it comes to technical tools for responsible AI that we're offering both on Azure and also on open source.
Cool. I think that's it from us. And hopefully, you would have enjoyed the series. And if you want to see the early episodes, as I said, we covered different aspects of AI models, different types of AI models, and the different tooling that is required for each of them, whether it is Azure Content Safety, whether it is Azure ML Prompt Flow, and today on the RAI or the Responsible AI dashboard as well. With that, we'll be back with some new series as well. Thanks, Ruth, for going to the workshops. And again, as I said, like these are available both on YouTube and on GitHub as well. So you can actually go back and look at them and actually send them to your friends as well. Anybody who couldn't attend this particular live session. Thank you so much. Bye.
Yeah. Thanks for having me. Thank you.